Hello and welcome to this video where we will outline the feature of Rational Power Management and RPM. The Rational Power Management feature was launched together with PLM Plus and D-series amplifiers. RPM allows for flexible allocation of power across the different channels. The way it works is that any power output of a PLM or D-series amplifier can deliver a total of 5,900 watts. If running power-hungry speakers on one channel while driving another channel with less demands, you can allocate more power to the more power-hungry channel. To demonstrate this, I have connected a PLM 12K44 to the network. I have configured it to be a three-way module. I have routed it like this: low, low, mid, high, which would represent any larger type line array system, for instance. To work with RPM in Lake, you need to go to Events and Control section, and then go further to Control. RPM exists in two modes, Custom and Auto. Auto RPM works in Lake Controller and bases its algorithms upon the ISVPL threshold of the Lake modules, meaning any existing modules that have ISVPL parameters will work with RPM as well. Many of you might be familiar with this page, but you might also see that there is some differences. The ISVPL speaker threshold has been there from start, and here's where we configure our output voltage peak power that we want to deliver to that power output. What's new is this actual ISVPL section, and here we can see what we actually get in reality. And this becomes very important when we use Rational Power Management. As default, a PLM 12K44 delivers 4 times 175 volt peak, but here is where it becomes interesting, because you can up the numbers here on any channel as long as you lower them on another. So let's say that we want more power to the low outputs. Let's say that we actually want the maximum voltage of these channels, which is 194 volts. We can see that the RPM label is appearing, which means that the RPM algorithm is active. What the algorithm now does is that it tries to allocate more power to this, and as you can see, we do have more power than 175, but since we still demand quite a lot on the other channels, the increase on the lows is not that high. But let's say that the high does actually not need the 175 volt, but rather 140 volt. We can see that the algorithm allocates more power to the lows. We're now at 191. We're still not reaching the ISVPL speaker threshold, which still makes the RPM text yellow. It would turn green if ISVPL speaker threshold and actual ISVPL is equal. So let's try and work with 160 volt on the mids instead. This does the trick. Now you see that the ISVPL speaker threshold and actual ISVPL are identical, and we do now have full output power, 5,900 watts into 3 ohms on the lows, because we lowered the power on the highs. And this, I think, represents a very large line array being driven with a lot of power, and I'm sure that many presets out there already looks like this, which means that many speaker presets that were configured for use with PLM 20,000Q, for instance, can now deliver actually the same output power with the PLM 12K44, which makes it, of course, very cost effective. Another way to work with RPM is to use the CAFÉ software. In CAFÉ, you set the RPM to custom mode, and you are able to set different output power depending more on the requirements of an install, for instance, where you want to adjust output power to match certain requirements. We hope that you will take benefits out of these features, and thank you very much for watching this video.